My name is Dina Weaver, and I work for Show Me Power Electric Cooperative. Normally, I would be traveling to different schools presenting electrical safety programs, representing your local electric cooperative. Due to all the craziness going on in the world right now, we decided to make a video so that you guys could see these programs from your own home. So, the first thing I want to talk about is how we make the electricity. You and I don't think about electricity until we don't have any. And when our electricity goes off, we're kind of like, well, I was going to do that, but I can't because we don't have electricity. So what I want to talk about first is all of the things that we use to make electricity. So I've got my poster here, and the first thing I want to talk about is coal. Because coal is the #1 thing in Missouri that we use to make electricity. And where we take the coal is a power plant. This big building is called a power plant. And we bring the coal in on the train, and we grind it up, and we burn it. Now, by burning the coal doesn't make electricity. You have to have 3 things to make the electricity. You have to have a generator, a turbine, and a magnet. And that magnet spins to get that electrical charge. Now, I have a piece of coal I want to show you to kind of give you a better idea. If we would grind this coal up and we would burn it, this would give us about enough electricity to have about 17 hours of internet. So you can imagine what a train load of coal would power up. The next thing is the wind. Wind turbines. And this is something that we don't see in Southwest Missouri. And the reason we don't see them where we live is because we actually just don't have that much wind, and we got too many hills. Something else is how tall they are. And I've got a poster that'll kind of give you a better idea. Here's the picture of the arch in St. Louis. It's kind of like a landmark in Missouri, and it's 630 feet tall. Here is a wind turbine. It's 405 feet. And then there's the Statue of Liberty and the U.S. Capitol building. And when you see them, you don't just see one of them, you're going to see a group of them. And I have a model of one right here. Missouri has wind farms, and they're located up in the northwest corner, north of Kansas City. The next picture is another power plant, and this power plant burns natural gas. And there again, by burning the gas doesn't make the electricity. What we have to have is a generator, a turbine, and that magnet again. The bottom picture is something you're a little more familiar with. This is at Table Rock Lake. You guys may have gotten to travel down to Branson and driven over the dam. Now, when electricity comes from the dam, that's called hydroelectricity. And there again, inside that dam is a generator, a turbine, and a magnet. The last thing that we use to make electricity is the sun. And this is a picture of a solar panel. And you guys may know somebody that has solar panels on their roof, or you may have seen a business that has them. And we're probably going to see more and more solar energy being used where we live. Now, once we get the electricity made, it's got a long way to go till it gets to our house. So what happens is it starts out on those really tall power lines first, and then it is sent to one of these. And this is called a substation. And a substation is not a good place for us to hang out. Very, very dangerous. So once the electricity gets to the substation sends it to all the power lines in the area. And then once the electricity is ready to come into our house, it can come in our house two different ways. So if you're outside playing and you look up at the roof of your house, and if you see a line that runs from your roof to the pole, your electricity is coming in that way. If you don't see anything connected to your roof, then that means your power lines are buried in your yard. My power lines are buried in my yard, but my neighbors are not. So it all kind of depends on where you live. And then we have to have the help of either one of these or one of these. Both of these are called transformers. And they've got a big job. The first thing they do is they just keep the electricity flowing because it's got that long way to travel. The next thing a transformer does, it can make electricity go higher or it can make it go lower. Because we have 7,200 volts of electricity out here on the power lines. So when electricity comes in our house, we don't want 7,200 volts waiting on us when we get ready to plug something in. So what happens is the transformer lowers the electricity. And that's why I have 120 volts flashing up here. That's how much electricity is inside your house, 120 volts. Now, the next thing I want to talk to you about is this. We all have one on the side of our house, or it might even be on the pole. If this one was really plugged in, it's going to have numbers, and those numbers move all the time. And this is measuring our electricity, and it's called the meter. We have to pay for our electricity, and so the electric companies don't guess how much electricity we use. They actually know because of this. The other thing that we all have is one of these. Mine looks a little different because it's small. I call this my tiny house, and I only have one switch. And this is the breaker box. A breaker box can be located anywhere in your house. Mine is in my basement, but a lot of times you'll see them in the laundry room or the garage, but they could be in your bedroom too. And mine only has one switch. So when I hit that switch, it takes away the electricity on this side of my board. Now I get asked the question, why is that still lit up? Well, it's on a battery. So when we're needing to stop the electricity, we go to the breaker box. Now, the next thing is I want to talk to you about these cords, because we use lots of cords. And I want to show you this cord because this cord was plugged in my bedroom. And I discovered one day, I looked at it and I thought something didn't look right. And there was wires popping out of it. Now, I got it unplugged and I didn't get shocked, so I was so glad that I had seen it. But I replaced it with this one. Now, this cord is pretty cool. When you plug it in, the end of it lights up. And it's got 3 places that you can use to plug things in. And when we're using cords, there again, we need to stop to think that electricity is running all the way through that cord. And we've got this plastic coating on that cord, and we can see how easily it is for those wires to pop out if we don't use the cord correctly. Now, you can run a cord under your bed, you can run a cord behind a bookshelf, but you don't want to cover up the cords because they can overheat. Also, when you are unplugging the cord, you don't want to go and pull the cord out like this. You always want to go and unplug it from the outlet. And when you're plugging something in, if it doesn't want to go in that outlet, don't ever force it. Something is wrong. Or if you ever see a flash of light come from that outlet, you want to make sure that you tell an adult. And something else about cords, you don't ever want to use them near the water. Water and electricity don't mix. Now, something else I want to talk about is this light bulb over here. The reason this light bulb is over here by itself, it's called a magic light. And I have an app on my phone that I can control that light. So I'm going to get my phone out And I'm going to pull up the app, and I'm going to see if I can turn that light off. I'm going to turn it back on. And then I'm going to see if I can change the color. I'm going to leave it right there. Now, this light is an LED light. And this is kind of like a gadget. I call it a gadget. That is super cool to have. We can control this light through our phone. So if we wanted a light to be on at our house at night and we were going to be coming in late, we could go to our phone, pull this app up, and be able to turn the light on from wherever we are. I'm sure some of you might have a video doorbell. We have all sorts of gadgets that control our heating and our cooling in our houses. I'm sure some of you have Echoes and talk to Alexa, and those are all really neat things to have. But I wanted to share my magic light with you. Now I'm going to go over here, and I'm going to talk about these light bulbs. These 4 kinds of light bulbs we can buy. I have all 4 of them in my house right now. And when I talk about light bulbs, I like to go back and talk about, well, who invented the light bulb? And there was a guy named Thomas Edison. And so we kind of owe him a lot because he came up with the first light bulb. Now, this light bulb has that wire inside of it, and it's got a funny name, and it's called incandescent. And this guy gets pretty hot pretty quick. I have a package where I bought my incandescent light bulbs. You can buy 2 light bulbs and pay probably about $1.50. The problem with these light bulbs, because they use so much electricity and they get so hot, they're going to last about 3 months, and then we have to replace them. The second light bulb is a halogen light, and it looks just like this guy, except it doesn't have the wire. And he doesn't get quite as hot, therefore he's going to last probably 5 to 6 months. The next light bulb is that only light bulb that has the tubes. And there again, he's kind of got a funny name, fluorescent or CFL. I bought a package of CFL light bulbs, and there again, they run about $1 for every light bulb. But what's the difference in this besides the way those tubes light up? Is how long it lasts. This light bulb is going to last us about 9 years. Now, this guy, I paid about $4.50, and I got 1 light bulb. This is the LED light. Now, I can put my hand here, and I can feel the heat from each of those light bulbs. But this one, I can grab a hold of it because it doesn't get that hot. And it's also plastic now. Now, let's check the LED box. The LED box is going to last 22 years. So we went from this light bulb to this one that's going to last 22 years. And when you think about that, that's incredible to think that a light bulb is going to last that long. So this is what I'm doing at my house. When one of the other 3 kinds of light bulbs burn out, I am replacing it with the LED light. And the electric companies tell us if we will take 5 of our main lights, so that would be like your kitchen, your living room, maybe your bedroom, your front porch, and you replace it with an LED light, that's going to save about $75 on your electricity per year. Something else that kind of made me think that the naming of these light bulbs. You got the funny word incandescent, you got halogen, you got fluorescent, and then LED, which makes it really simple to remember. But those letters stand for something. They stand for light emitting diodes. And you can go on the internet and read all sorts of information about how they come up with that light bulb. Who knows, maybe you guys can figure out a light bulb that never burns out. Now let's look down here at my sink. I've got a pretend little sink here, and this is a flat iron, and it has fallen in the water. And our reaction is to grab it and pick it up. But electricity and water don't mix. So let's talk about this outlet right here. So when you're brushing your teeth, I want you to look for this outlet. The outlet in my bathroom has a red button and a black button, but both of my buttons are white on this outlet, so it's a little hard for you to see. For a long time, I would just call this my special outlet, but it actually has a name. And here it is. It's called a GFCI. And I'm going to tell you what that stands for. It stands for Ground Fault Circuit Interrupter. It interrupts the electricity. So let's see how it works. Now, both of the buttons have words on them. They have the word test and they have the word reset. So let's see what happens when I hit the test button. I have turned the electricity off. It's stopped the electricity, so now I can unplug the flat iron. I can put my hand in there, and I didn't get shocked because I stopped the electricity. Now I can hit the reset, and it brings the electricity back. So that's why the outlet is in your bathroom. Now, you might find these outside your house too. I have one out on my deck. And the ones we have outside of our house have a kind of like a silver door on them. You open it up and you will see that same outlet on the outside of your house too. We've talked about light bulbs. We've talked about how electricity is made. We've talked about the meter, the breaker box, and we've talked about that special outlet, GFCI. Now, a couple of things I want you to know about electricity. Electricity loves us. And there's a reason why. We are full of water. And electricity loves water. And I have something I want to share with you, and it's called an energy stick. And so just to kind of give you an idea of how electricity loves us, I'm going to put my hand here, and I'm going to put my hand here, and this is representing how electricity would flow through us. Electricity wants to go to the ground. That's just what it wants to do, and it wants to take the shortest path to get there. So if that means going through us, that's what it's going to do. And if it did that, it could hurt us really badly. Now, normally I would have you guys ask some questions and hopefully be able to answer them. But since we're doing this video, what we're going to do is I have a couple of links that I'm going to share, and we're going to attach it to the bottom of the video. And hopefully you can do some projects on your own. I would love to be able to see some pictures of the projects or things that you are doing or learning about electricity, since I'm not able to come in the classrooms with the craziness that's going on in the world. But I sure miss seeing you guys, and I want you to have a really safe spring and summer. See you soon.